Welcome to NYNJPA Weather Educational Videos. This first education video from NYNJPA Weather, we're going to talk about upper level wind dynamics and what that means for you and for forecasting the weather when you're dealing with an extratropical storm, a hurricane, or just severe weather. So we're going to look at two specific levels today. We're going to look at the upper level winds for 250 millibars and 300 millibars. At 250 millibars, we look at key indicators for storms, divergence, convergence, where the upper level winds are slowing up and where the winds are weakening. We're looking at divergence enhancement. And under this level, we generally see the majority of the focus from polar and Arctic jet streams. At 300 millibars, that's where we start to get key indicators of where moisture is going to come from. Your subtropical jet stream, that jet stream usually rides right along the Gulf of Mexico, for example, is enhanced by 300 millibar winds, and it's a key indicator on exactly what's happening in the subtropics when we start to develop these extratropical storms in the winter. So we're going to talk about those two key factors and look at some of the 500 millibar indicators for winter storms, because, well, let's face it, everyone's thinking about the next winter storm. Okay, we're going to start off first at 250 millibars for a winter storm that happened back in January 12th, 2011. Now, I'm going to be a bit basic here in my discussion of how to use these upper level wind dynamics and these observations. There's going to be a lot more information involved when you actually go to college and really go through all the courses on dynamics and multivariable calculus and mass divergence and all that other good stuff. But for this video, so it doesn't last about 5 or 6 hours long, we're going to talk about just some basic fundamentals in terms of jet streak dynamics. Now, in the case of this winter storm, we had a nice little winter storm that was blowing up around the Philadelphia and New York City metropolitan area in this situation. And you see this area right here, this is what's called a jet streak. This is a very important feature to keep an eye on. When you are to the north and northeast of a jet streak, right in this area here, that's where the best divergence is occurring aloft. When you are to the southwest of a jet streak, that's where the best divergence is also happening. So you have divergence here and here. Now, why is divergence important? Divergence and diffluence. Diffluence is stretching in the atmosphere because of increasing speed, and divergence is due to the location of where that wind is rapidly exiting. Those two factors leads to basically rising air from the surface to the upper levels, and the faster that air rises, the stronger your storm. So when you have an area of low pressure, let's say right around the Delmarva, move into an area of divergence and diffluence, that means that the whole engine of the storm is basically becoming amped up. You're throwing nitro into the tank of your car, and you're really enhancing the ability of the low pressure system to evacuate mass, in other words, an air mass, from one location to another. That's basically what a storm is. A storm is simply the balancing out of energy and mass from a warmer air mass to a colder air mass and vice versa. So in this case, what we're seeing here at 250 millibars is a divergence, a movement of air from one location to the other, enhancing the rising motion in the atmosphere. So when we're forecasting winter storms, what we want to look for is where is this jet streak setting up in relation to the storm track. Another key point here is, you see this right here? You see how the winds are coming together here? This is called convergence. Now, convergence is just as important in a winter storm as divergence. Why? Because the stronger the convergence that we're seeing here, we see that, notice the winds are coming together here, they're coming together here from the south and from the west. When you're having that develop, that leads to surface high pressure systems becoming enhanced. Now, it doesn't stand out all that much on a weather map. And when you're looking at it, you're looking at all the bright colors, you're looking at the blues and the strong winds here associated with these darker blues here. But keep an eye on this area here. That's just as important or even more important than anything that's happening here. Why? Because the convergence, the focusing of mass in this area here leads to sinking air, and sinking air enhances high pressure. And if you have a strong high pressure system right around, let's say, Maine or right around the St. Lawrence River Valley, that's more likely to keep cold air at the surface in place. So you see how upper level winds, even at 250 millibars, can significantly enhance a storm. Now, this is just the polar jet stream and Arctic jet stream here at play here. You can see a pretty strong focus with the polar and Arctic jet stream here, especially over the Pacific. But what about 300 millibars? Well, 300 millibars is where I like to look at the subtropical jet stream. Now, again, you have to really look at the devil in the details. Now, notice at 250 millibars, we're seeing some focus of a jet streak here, but we don't really see a real focusing of the winds or the pressure here at the Gulf of Mexico. It's more focused well out into the Atlantic. You see all that air moving out right into the Atlantic. However, you can see a little bit more of a packing influence here at 300 millibars. Our jet streak is over 150 millibars. We have an upper level low starting to form here. Why is this all important? Because this factor is the subtropical jet stream. This part of the jet stream right here, which typically involves a lot of Pacific and tropical moisture. When we're talking about all that convection forming around the date line every week, especially all you premium members out there, well, the reason why is because the more convection you have developing, the more of these little disturbances you have come into play, even under this ridge with the polar jet stream. And those disturbances, see like right here, can enhance the winds. And that slight enhancement, when it combines perfectly with the 250 millibar winds, really starts to amplify and enhance a low pressure system. So as you can see here, we have a lot of strong divergence aloft. We're seeing strong lifting here and strong lifting here. We're also starting to see what we call convergence aloft over portions of the St. Lawrence River Valley. So in this scenario, if we were to look at it and we're trying to forecast a storm, what do we know? We know we're going to have strong cyclogenesis along the East Coast. We know we're going to have a strong influx of moisture coming in from the Pacific and from the Gulf of Mexico due to these winds. Notice now they're more northwest to, should I say, southwest to northeast than they are from west to east, which means we're definitely drawing more moisture in from the Gulf of Mexico in this setup. We also know we have plenty of convergence developing over portions of the St. Lawrence River Valley at 200 and 300 millibars, and that means sinking air, and that, of course, means one very important factor: cold air is going to be locked in. So as you can see here in this situation, we clearly have the support of several dynamics coming together to support a major winter storm. We also have to take an eye on here. Okay, keep a focus on what's happening on the base of this trough. Why? The reason why we need to watch this portion of the trough at 250 millibars and at 350 millibars or 300 millibars is that a strong jet streak in this area can do two things. It could cause the trough in what we call becoming negatively tilted. In this case, it's somewhat negative, but let's say we're trying to find out whether a storm's going to cut off or potentially stall. Well, what you want to look for is not here, but here, over the west. Think of it like basically a dumbbell falling into a bucket of water. You have all your focus and all your momentum on one side of the bucket, right here. Okay, this is our bucket, and here's all the focus, here's all your mass, right? So you're thinking, okay, the storm's focused here, there's nothing to worry about here. But what happens is that if you drop more mass into the back side of this bucket here, what happens is that it forces this trough axis to tilt even more negative towards the northeast to balance out that mass that has been added. So if you see a strong jet streak on the back side of this trough to mirror the strong jet streak on the eastern side of the trough, what we're looking at here is a intensifying trough that will have the potential to form a cutoff low that will have the potential to form a slowing winter storm. So again, the devil's in the details, and you have to keep an eye on what's happening on the backside of this trough just as much as what's happening on the eastern side of the trough. Moving forward, let's look at today. Today, again, it's September 23rd. So the weather events out there aren't really all that, impressive. It's quiet out. High pressure's in control. And you can see at 250 millibars what's happening here throughout the atmosphere. We have a nice large ridge over much of the eastern and central United States, but we also have a strong trough out here in the Atlantic. Now, remember, we have high pressure in control. Where is that high pressure system setting up? Area convergence here, but also with a strong storm developing in the Maritimes, Canadian Maritimes, we also have a rather impressive area of convergence here, right where this trough and this ridge starts to meet. So that area of convergence enhances high pressure around the Canadian Maritimes, around, let's say, Quebec, and that supports two areas of high pressure, one of which will take control for the rest of this week and remain in control with very tranquil weather conditions. Meanwhile, over the Pacific, we have another jet streak. Now, this one is even more interesting because remember I told you about the back end of this trough being a key factor here when you're looking at storms. This jet streak here tells me that this whole trough is going to intensify. And the forecast based on this strong jet streak does show a very strong upper level low taking shape over the Gulf of Alaska that will eventually shift back towards the Aleutian Islands. But none of that would be possible without this enhancement of the jet streak here that enhances mass divergence over the Gulf of Alaska to kickstart the formation of a powerful storm. So you can see how you can use the jet streaks and how you can use the position of upper level winds to determine exactly what's going to happen and how it's going to happen at the surface. So when you have a strong jet streak, remember the northeastern or eastern side of this jet streak and the southwestern side of the jet streak are where you're most likely to see the best potential for storms to form. The northern portions of the northwestern and southeastern locations of the jet streak is where you're most likely to see convergence aloft. And of course, wherever you see isotherms here, or pressure lines, start to converge, or height lines should I say, isotachs start to converge in one area, that's where you have convergence aloft, obviously, and that's where you could develop a strong surface high pressure system. Taking a look at 300 millibars, basically the same scenario. Notice our subtropical jet stream right now, because of a weak El Nino, or actually no El Nino at all, it's really not all that impressive, but you could see how there's a little bit more of a focus towards the subtropical jet stream, and a little bit more focus of the upper level divergence and dynamics here than in the previous 250 millibars. So again, each level is important, and each one you have to watch and keep an eye on. And finally, when we zoom in a little bit closer towards our neck of the woods, you can see winds are pretty light here, really not much going on throughout the United States. But you see how this jet streak is pretty strong? This jet streak is going to help to enhance a trough over the western United States over the next couple of days until we start to see another pattern change just in time for October. Well, that is your education video for today. I hope it's been helpful. Of course, I'll have more each week as we look at different processes in the atmosphere. And if you have any questions or looking for more information about other weather events, just let me know because I'll include them in videos in the future. I'm your meteorologist, Stephen DiMartino. Have a wonderful day, and of course, as always, stay safe out there.